Unit, we will be looking at topographic maps. Topographic maps are more than just a road map. There's a lot more that you can find out by looking at a topographic map, including the elevation, roads, rivers, landforms. You can find elevations like how tall a mountain is, or how deep a valley is, how steep a landform is. So we can find a lot of information. So let's look at some topographic maps. So the first thing we need to know about topographic maps is the lines on the map are called contour lines. So contour lines are lines that connect points of equal elevation. So for example, this 700 line means that every point that touches that line is 700 feet above sea level. The 800 line, every point that touches that line is 800 feet above sea level. The distance or change in elevation between two lines is called the contour interval. In this map, the contour interval can be found by taking the distance, the change in elevation from this one, which is 700, to this line, which is 800, so the difference is 100, and dividing it by the number of steps to get to the next line. So 1, 2, 3, 4, 5. 100 divided by 5 is 20, so the contour interval of this map is 20 feet. That means that every line represents a change in elevation of 20 feet. So if we're looking at two maps side by side, the map that has very few lines and the lines are far apart is a flat surface, meaning there's not a lot of hills or change in elevation on this map. The map on the right, you can see, has a lot of lines, and the lines are close together. The closer together the contour lines, the steeper the slope. So this represents a large change in elevation, so these are mountains. We can also look at a topographic map and create a profile or a side view of the map to determine what we're looking at. So in this map, we see closed circles, so we know it's some kind of hill or mountain. When we look at the profile, we just bring the contour lines down and graph them, and it creates a side view. So you can see now we have a side view of the hill that represents what we were looking at in the topographic map. So you can generate a profile of a topographic map and see what the shape of the landform is. On the STAAR test, you are likely going to be asked to look at a topographic map and then match it up to the correct profile view. So let's look now at how we can determine whether which direction the water is flowing on a topographic map. So water always flows downhill. So we can look for the elevations, the change in elevation. Okay. So in this map, we're going to look for the change in elevation. So I'm going to be looking at this river right here. I'll circle it. Okay. And in that river right there, we're going to determine which direction the water is flowing. So you can see this contour line is labeled 2100, but this contour line is labeled 2000. So 2100 is higher than 2000, so the water is going to flow downhill. So we can determine that the water is going to flow northeast. Okay. We can also look for the V in the contour lines. So when the contour lines cross the river, they make a V, and that V will always point uphill. So again, looking at the same river, we can see the V's in the contour lines, and those V's point uphill or upstream where the water is coming from. So again, we determine that the water is flowing in the northeast direction. I'm sorry, northwest. Another way to determine which direction the water is flowing is if the lines, two river streams, come together, where they meet, the V points downstream. So the V will point in the direction that the water is flowing. So in this situation, the V is pointing downstream here and here. And so we can see that the V is actually pointing, in the direction that the water is flowing, which is downstream. Okay, so the water in this map is flowing more towards the south. Our next topic is going to be plate tectonics. Now, I want to make sure that you understand the difference between plate tectonics and continental drift. So on your paper, write continental drift and then write plate tectonics below it. So let's first talk about what continental drift is, and I would like for you to write down a brief explanation of continental drift. Continental drift was a theory that was proposed by a scientist by the name of Alfred Wegener. Alfred Wegener proposed that the continents were once together as a supercontinent that he called Pangaea. Alfred Wegener had lots of evidence to prove that the continents were once together, but what he couldn't prove was how the continents were moving. And so that's where plate tectonics comes in. So next to plate tectonics, write down plate tectonics is the movement of large plates of the Earth's crust through the process of convection. The key word there is convection. Convection currents inside the mantle are the cause of plate tectonics. And that's a very important concept to remember. So there are three types of plate boundaries when we're looking at plate tectonics. There's convergent plate boundaries, divergent plate boundaries, and transform plate boundaries. So I'm going to start with the easiest of the three, and you should take notes on your notebook paper on each of the three. The transform boundaries is the easiest, so I'm going to start with that one. Transform boundaries are a plate boundary where the plates are sliding past each other. This would result in earthquakes. Now, earthquakes happen at every type of plate boundary, so that's not very significant. There's no landform that really forms at transform boundaries, but transform boundaries are known for their earthquakes. And our most relevant example of transform boundaries is, of course, the San Andreas Fault, which is located in California and responsible for the earthquakes that occur in California. Divergent plate boundaries are plate boundaries that are dividing or moving apart from each other. So we have divergent or divide. So there's a couple of key points to remember here. If the divergent boundary is ocean to ocean, meaning the ocean is opening up, we call that seafloor spreading. And that's where the newest rock on Earth can be found. New rock is made in the middle of the ocean floor where the seafloor is opening up. And so seafloor spreading is the result of, or is what causes the formation of the mid-ocean ridge. And that mid-ocean ridge, again, is where the newest rock on Earth can be found. If the divergent boundary is continent to continent, meaning the continent is opening up, then we call the formation that occurs from that is called a rift valley. The example would be the Great Rift Valley in Africa, and both sides of this valley are surrounded by fault block mountains. So these large mountains, and it almost looks like stair steps on both sides of the valley. That's a rift valley. All right, so let's look at convergent boundaries because there's several different types of convergent boundaries. If two continental plates converge, they are the same density and they will result in the formation of mountains. The best example of this, most commonly referenced on the STAAR test, is the Himalayan mountains. The Himalayan mountains formed when India collided with Eurasia and formed these folded mountains, and they call them the Himalayas. So that's convergent continent to continent. If an ocean plate and a continental plate collide, then what will result is a deep ocean trench just off the coast of the continent, and on the continent we'll find volcanic mountains. So you'll get volcanoes lining the continent, the edge of the continent. The example here is the Ring of Fire. This is the type of plate boundaries that are occurring around the Pacific Ocean. And so the Pacific Ocean is surrounded with deep ocean trenches along the coastlines. And then on the coastlines, we have volcanoes all the way around the Pacific Ocean. And we call that the Ring of Fire. The last example would be if it was ocean to ocean convergence, meaning that the two ocean plates are colliding with each other. If that happens, the more dense or older ocean plate will subduct or go under the younger oceanic plate, and we'll get underwater volcanoes. Eventually, those underwater volcanoes will erupt and come above the water and form a volcanic island. We call those hot spots. So the resulting format, the formations, what we look at, you can say that the formations that occur at plate boundaries can be earthquakes, volcanoes, mountains, and trenches. All of those are very commonly found around plate boundaries.